Permutations and combinations, and there's also the fundamental counting principle and so on in there. So let's hide this. Okay, we're going to start out with the fundamental counting principle, which says if event M occurs in M number of ways and event N occurs in N number of ways, then if you have two events, M followed by M, and they're independent of each other, then it'll occur in M times N ways. Okay? So, here's how it works. So, let's say you go to your closet and you have two different things to wear on your legs. You have blue jeans or black pants. And you have three different shirts that aren't dirty. Okay? So, how many different outfits can you make out of that? Well, 6 different outfits. 1, 2, 3, 4, 5, 6 different outfits. Okay? So, you take the 2 pants times the 3 shirts, and you can make 6 different combinations of outfits. Okay? Pretty easy to make a little tree diagram out of that, right? Well, what if you have this situation where you have 6 different sandwiches? I should change colors here. Let me change colors. Draw. Let's, instead of being green, let's go, ooh, hot pink. There we go. Woo! Okay, so we have 6 different types of sandwiches, 4 different sides, and 5 different drinks. Would you like to make that tree diagram? I sure wouldn't, because that'd be a whole lot of lines. You'd have to take 6 times 4 times 5, 120 different combinations. Okay, you could have a salami sandwich with chips and iced tea, or a club sandwich with potato salad and lemonade, or so on. You have 120 different combinations because there's 6 times 4 times 5. Okay, that's a fundamental counting principle. Okay, so suppose your computer generates a password that begins with a letter followed by 2 digits, like R38. How many different passwords can you make out of that? Well, the letter is, how many letters are there in an alphabet? 26. So then first digit, how many combinations of numbers can you use for the first digit? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 10 numbers. How many numbers for the second digit? 10. So 26 times 10 is 2,600 passwords with just a simple letter and then 2 numbers. You got 2,600 different combinations. You would be trying it for quite a while to figure it out. So, a permutation is an arrangement of items in which the order of objects is important. You can use a fundamental counting principle to find the total number of permutations. Suppose you want to find out the number of ways to line up 4 friends. Okay? So, there's 4 ways to choose the first person, 3 ways to choose the second person, 2 ways to choose the third person, and 1 way for the last person. Okay? So, it's 4 times 3 times 2 times 1. Okay? A way we write this is called 4 factorial. It's 4 exclamation point. Now, 4 exclamation point doesn't mean 4! Okay? I use 4 with an exclamation point. That's not what it means. It means 4 times 3 times 2 times 1. So if we had 15 exclamation point, it doesn't mean 15 yelled out really loudly. So Audrey jumps in the air. It means 15 times 14 times 13 times. That's a lot to type into your calculator, isn't it? If there was only a button on your calculator that would help you out with it. So those of you who don't have your calculators out yet, this was a hint, hint, hint. All right, so we're going to do this 15 factorial on your calculator. So you're going to hit the number 15. hit the button that is PRB. Find the exclamation point and hit enter or equals. PRB.
Wow.
15 factorial is gigantic, right? Yeah. That's super gigantic. Okay. Let's take something smaller like 12 factorial. What's 12 factorial?
I don't know how to say it.
479 million. 001600. 479,001,600. So if you have 12 books just sitting on a table, and they're all like different books, one math, one science, one whatever, one romance, and you want to put them up on a shelf, you have over 479 million ways to arrange those 12 books on the shelf. The wildness of math. All right. Oh. All right. So, what happens with permutations is they're not always going to be that big. So let's say out of 10 people, we are going to have one president and one vice president out of this group. And instead of electing the president and vice president, we're just going to draw their name out of a hat. How many different ways are there to find the president and vice president out of a group of 10 people if we're going to just draw them out of a hat? Well, what is 10 factorial going to be? Something really big.
3,628,000.
So 3,628,800, right? That's a number of possible combinations of putting things in order, but we're only having 2 people, okay? So we're going to divide out of that 10 people. So then we're going to take 10 minus 2, which is 8 factorial. So we're going to divide this by 8 factorial. What's 8 factorial? What? 40,320. So the number of combinations of people that can get drawn out of the hat is a lot less. So if we divide these two, what do we get? So there's 90 different ways of, if you draw 2 people out of a hat, out of a group of 10 people, there's 90 different ways to get a president and a vice president. Okay? Because order is important. Okay? A president is different than a vice president. Okay? So, if you want to play 3 songs if you have 8 songs on your MP3 player and you want to play 3 songs of that, it would be 8 factorial over 8 minus 3 factorial. Okay? Or it winds up to be 336 ways of playing those songs. Okay? Now, there's another button that can help us much easier with this. And it's the NPR button. Okay? So, if there's 8 songs and we want to play 3 from it, we go 8 and then hit the PRB button. Find the NPR, hit the 3, and then hit equals. What do you get? 336. So that's called a permutation. So if 12 swimmers are in a race, and we want to know how many different ways those 12 swimmers can finish first, second, or third, we'd go 12 permutation 3 because there's three different types of finishes, first, second, and third, okay, out of the 12 swimmers. So if you go 12 permutation 3, what do you get? Quite a few ways. 1,320 different ways you can put those kids into first, second, and third, okay? All right. A permutation order is important. You got a first person, a second person, a third person, a president, vice president, so on. A combination order is not important. So it's like city councilman. Okay? Or, yeah, let's do the city councilman first. Okay, let's say you have 8 people that are going to run for city council, and you're going to put the names on the ballot. But you can't put their names in alphabetical order because then the person with the first letter sometimes gets the vote because some people just mark it at the top. Oh, I don't know these people. I'll just pick the first 2. So everybody wants to be at the top of the ballot, okay? Because there are people that are stupid enough to walk into the ballot box and just check the first 2 and call it good. So if there's 2 positions open for city council, does it matter between the first city councilman and the second city councilman, or are they equal? Because president and vice president aren't equal, are they? But are 2 city councilmen equal? Yes. So if the order doesn't matter and you want to put their names on a ballot, okay, and the order doesn't matter as far as who goes first, second, third, fourth, then what it's called is a combination. So it's 8 combination 2. And I bet on your calculator you have an NCR too. Now, when it's a combination, it's a lot less possibilities. Okay? How many possibilities is 8C2? Just 28 possibilities. Go 8P2. How many is that? Okay, a lot more with a permutation than a combination. So what a combination is the total number divided by the number available times the total number minus the number available. Okay, and it gives you a lot less. Okay, so suppose you choose to read 4 books on summer vacation from a reading list of 12 books. Does it matter the order that you read them in? No, if they're just 12 random books. Now, if you're reading The Lord of the Rings, you'd want to read the first one, then the second one, then the third one. Because if you read the third one first, you'd be really lost on what's going on if you don't read them in order. But if you're just reading 4 random books, order is not important. So you'd go 12 combination 4, and you should get 495. Let's say a service club has 8 freshmen, and 5 freshmen are picked to be on the cleanup crew. Ooh, the bad job. Okay? How many ways can you pick out of the 8 freshmen that you get 5 people on the cleanup crew? How many combinations are there that would give you 5 out of the 8 people? There's only 56 combinations of picking 5 kids out of 8. Okay? All right. So if order is important, it's a permutation. If order isn't important, it's combination. So a college student is choosing 3 classes to take during the first, second, and third semesters of 5 elective classes offered in his major. Now, would that be a permutation or a combination? Because they're going in different semesters. One in the first semester, one in the second semester, one in the third semester. That would be a permutation because order is important of when it is happening. A jury of 12 people is selected from a pool of 35. Does it matter juror number 1 versus juror number 2 versus juror number 3? If it doesn't matter the order, then it's a combination. So it'd be 35 combination 12 or 834,451,800 to pick 12 people from 35. A yogurt shop allows you to choose 3 of 10 possible mix-ins for a just right smoothie. How many different possible just right smoothies are there? Would that be a permutation or a combination? When you get to choose 3 of 10 toppings, basically. Does the order that they throw the toppings on important? No. So it'd be a combination. 10 combination 3. Okay? To figure out how many smoothie combinations are there. How many smoothie combinations are there? What? 120 different combinations. All right. And then we're going to use a different method for that. So let's go and see what kind of homework problems there are so you kind of have a better chance of getting through them. All right. 4 exclamation point is not 4 and me yelling really loud. It's 4 times 3 times 2 times 1, which is 24. 9P5 and 5C2, you know how to do already. All right. For a radio show, a disc jockey plays 6 records. There's 11 records to select from. And how many ways can the set program be arranged? Is order important when they're playing records in a certain order? Yes. Okay, when you're playing in a certain order, yes, they are. So it's a permutation. So it'd be 11 permutation 6. What is that on your calculator? What? 332,640. To create an entry code for a door, you use 2 letters and 4 single-digit numbers. How many different entry codes can you make? Well, if it's 2 letters, how many possibilities out of those 2 letters? There's first letter is 26. The second letter is, and then single-digit numbers 0 to 9. There's 10. So what's 26 times 26? That's like 576, right? 676. So there's 676 with 4 zeros behind it. So there must be 6,760,000 combinations for that entry code if you use 2 letters and 4 single-digit numbers. Okay? All right. Baby Edgar wants to put 9 blocks in a row. How many different arrangements can Baby Edgar make? Is order important? Yeah, it is. Okay. So it's 9 permutation. How many blocks are there? 9, right? What's 9 permutation 9? What? Go 9 factorial once. What is that? 362,880, right? 9 permutation 9 and 9 factorial are the same thing. So if you're lining up things, you could just go factorial instead of permutation. Okay? A locker contains 6 books. You must select 3 books at random. If you're just selecting things at random, does the order matter? No. So it's a combination. Election ballot. 4 city commissioners out of 15 candidates. Combination or permutation? City commissioners now. Order important? Nope. So it's a combination. 15C4. Okay. To win a lottery, this is the tough one. To win a lottery, 7 numbers must be drawn from a pool of 52 numbers. Numbers cannot repeat. So it's like those little ping pong balls that they draw out. Number 7, number 21, and so on. Okay? The numbers can't repeat. If you have a lottery ticket, what's the chances of you having the winning lottery ticket? Okay? Well, what's the chances of you having the number right with the first ball of 52 balls? If there's 7 numbers that are going to be drawn. You have 7 numbers on your sheet of paper and they draw a number. Your chances of having that number is 7 out of 52. Then how many numbers do you have left on your sheet of paper? 6. How many balls are left in the hopper? 51. And you multiply these times each other. So 6 times 51, 5 times 50, 4 times 49, 3 times 48, or 3 out of 48, times 2 out of 47, times 1 out of 46. Now, your calculator can't handle this. Trust me, it can't make a fraction out of this. So what do we have to do? We have to reduce our fractions. Okay? Now, I know 5 goes into 50 1 out of 10 times. Okay? So that one's been reduced. I know 6 goes into 51. They're both divisible by 3. 2 and 17 times. Because 3 times 17 is 51. Does 7 go into 52? No. 7 doesn't go into 52. Does 4 go into 49? No, 4 doesn't go into 49. Does 3 go into 48? 1 and 16, right? Does 2 go into 47? No, and 1 doesn't go into 46. But we can still do some reduction. 7 goes into 49, right? 1 and 7 times. And 4 goes into 52 how many times? 1 and 13 times. And 2 goes into 16 how many times? 1 and 8 times. And 2 goes into 10, 1 and 5 times. So the whole top row is just 1 times 1 times 1 times 1 times 1 times 1 times 1, right? The bottom row is where we do our multiplying. You take 13 times 17 times 5 times 7 times 8 times 47 times 46. Do that, somebody. It's a big number. The chances of you winning the lottery is 1 and 33,784,560. So if you have 7 numbers on your lottery ticket and there's 52 balls in the hopper, you have a 1 in 33, almost a 1 in 34 million chance of winning that lottery. Yeah. Hey, but you're saying there's a chance. What movie is that from? Ooh, it was a classic back in the day, but you guys are so young. They're driving a van with a dog, like dog ears. No, big dog ears. Dumb and Dumber. There we go. So you're saying there's a chance. All right. Yeah. Then you'd have a 5 in 33 million chance. Yeah, and get it.
Then you might just win.
All right, for a segment on a radio show, a disc jockey can play 8 records. There's 13 records to choose from. So that'd be 13 permutation 8. All right. Choosing flowers to put in a bouquet. Does the order matter? Just throwing flowers in doesn't, if they're just putting them in wherever, that would be a combination. So, oops. Bigger number always goes first. 11 combination 6. Okay, so I will hand out that worksheet. You will work till 2:30, and then I'll start going over the next section. When are you going to finish this? What? Yeah, maybe. You owe me a couple worksheets.
10.